Boeing, the biggest American aircraft manufacturer, is once again in the headlines for the wrong reasons, facing a fresh crisis tied to the safety of its popular 737 MAX and even some older 737NG planes. Recently, the National Transportation Safety Board issued an urgent safety alert focusing on the potential malfunction of these planes' rudder systems under specific conditions. This malfunction could cause the rudder to jam or become restricted, which poses significant safety risks as it directly affects the aircraft's ability to control direction during critical flight maneuvers, including coordinated turns, crosswind landings, and emergency responses like engine failure. The latest safety concern emerged from an incident involving United Airlines Flight 1539, a 737 MAX 8 operating from Nassau in the Bahamas to Newark, New Jersey, on February 6, 2024. The aircraft was initially ordered by Air Italy, but was later acquired by United Airlines in 2020 after Air Italy ceased operations. During landing at Newark, the pilot faced an unexpected challenge. The rudder pedals, critical for maintaining the aircraft's directional control, seemed to lock up. When the captain, who was flying, attempted to steer the plane along the runway using the rudder, he quickly noticed that the rudder pedals weren't responding. In response, the captain switched to using the tiller, a device typically used for steering the aircraft during taxiing at lower speeds, to keep the nose wheel aligned with the runway's centerline. Following the landing, both pilots found that kicking the rudder pedals forcefully eventually loosened them. Maintenance engineers initially could not identify any obvious fault within the rudder mechanism, but data from the flight recorder confirmed that the rudder system had indeed jammed during the landing roll. United Airlines then conducted a test flight, which shockingly replicated the problem. This further validated the pilot's concerns and suggested a potential underlying issue that needed deeper investigation. The incident prompted the NTSB, in collaboration with Boeing, United Airlines, the Federal Aviation Administration, and Collins Aerospace, to launch a comprehensive investigation. The investigation team traced the issue to a component called the rollout guidance actuator. Collins Aerospace designed this actuator to support the autopilot's functions, particularly during low-visibility landings, by maintaining alignment with the runway's centerline. When the NTSB exposed this part to cold temperatures similar to those at high altitudes, the actuator demonstrated the same jamming issue, suggesting that moisture may have entered the part and subsequently froze, obstructing its movements. This actuator wasn't even supposed to be active. When United purchased the aircraft from Boeing, they requested that Boeing deactivate this feature, as it was not part of United's regular fleet configuration. Nonetheless, the part remained installed and linked to the rudder mechanism, causing issues once it froze. The rollout guidance actuator was specifically included in the aircraft's design to support Air Italy's requirements for conducting Category 3 Bravo auto landings, a highly automated landing procedure that allows the aircraft to land and maintain the runway's centerline with minimal pilot intervention. United Airlines, however, didn't use this auto landing feature on its other 737 MAX models, which is why the actuator was disabled. But even though the actuator was no longer operational, its physical presence on the aircraft's rudder mechanism allowed it to affect the rudder once it became jammed due to freezing. After the February incident, United removed these actuators from the remainder of its fleet, and Boeing informed other airlines about the potential issue. The NTSB, however, has insisted that simply notifying airlines isn't sufficient and urged Boeing to develop alternative response procedures that reflect both in-flight and post-landing scenarios where rudder jamming could create a serious hazard. With the February incident, the actuator's vulnerability to cold weather was exposed. The NTSB revealed that other airlines also experienced similar issues in past years. Collins Aerospace reported that an assembly error during the production of these actuators caused the vulnerability. The improperly assembled part allowed moisture to enter, which then froze at high altitudes and led to the jammed rudder system. Collins Aerospace has identified around 353 rollout guidance actuators that might have been affected. These components could be installed on various 737 models, both NGs and MAXs, making this a more widespread problem than initially assumed. To mitigate risk, United Airlines promptly removed these components from its fleet, and Boeing clarified that the actuator's design wasn't inherently flawed, but compromised due to improper assembly. The NTSB's safety recommendation calls on Boeing to reassess its guidance for dealing with rudder jams, especially during high-stakes situations like landing, where rudder failure could lead to dangerous runway excursions or loss of control. The situation underscores the importance of pilot training and emergency response measures. The NTSB suggested that pilots should have alternatives beyond brute force to resolve rudder issues. They emphasized varying responses, depending on whether the jam occurs during flight or on the ground. This incident has sparked a larger conversation about Boeing's quality control protocols and the communication channels between Boeing and its parts suppliers. While affected airlines acted swiftly, the recurring safety issues with Boeing's 737 models raised concerns for passengers, the public, and aviation professionals. The NTSB recommended the FAA and Boeing improve notification systems to ensure all operators worldwide are fully informed of potential risks and trained to handle rudder jams, particularly in foreign markets where some carriers may lack direct access to updated guidance. In the broader context, Boeing has committed to enhancing its oversight mechanisms to address such component failures proactively. As the NTSB investigation progresses, Boeing may be required to adjust its supplier partnerships and quality control procedures to prevent similar problems in the future. This highlights the critical role that even the smallest part plays in an aircraft's overall functionality and safety. The incident shows that minor component defects, like improper actuator assembly, can have widespread effects, especially when they affect crucial systems like the rudder. As the industry awaits the final investigation report, there is a heightened focus on Boeing's responses to quality control and component reliability issues. While the rollout guidance actuator problems may not be widespread across all Boeing aircraft, they serve as a stark reminder of the rigorous attention required for maintenance and safety inspections. The case reveals the interconnectedness of aviation systems and how a single part's malfunction can lead to extensive operational changes and safety advisories. For Boeing, the ongoing scrutiny adds pressure to ensure that its products meet the highest safety standards and that airline operators, especially those with smaller fleets, are kept well informed of potential safety updates. The company's swift action following the United Airlines incident indicates its commitment to addressing safety concerns. As we await further findings, the Boeing 737 rudder issue underscores the importance of stringent oversight, effective quality control, and timely communication across the aviation industry. The incident's complexity reflects the broader challenges Boeing and other aircraft manufacturers face in producing reliable, safe aircraft while incorporating advanced automation technologies. Thanks for watching. Please, as always, like and subscribe to my channel.